In a general sense, algebra is a formal symbolic discipline. The discipline is defined by abstraction and regularity. The language used is neutral and deliberately restrained. There is no emphasis placed on interpretation or application. The presentation proceeds slowly and without variation. We may now consider the concept called a variable. A variable is a symbol used within algebraic expressions. The symbol represents a quantity that is not specified. This lack of specification is an inherent property. It is not temporary and it is not resolved. The variable does not describe a concrete amount. It merely occupies a formal position. The position exists independently of value. It can be observed that the symbol remains unchanged. Only the possible assigned value may differ. This difference is not expressed within the symbol. The symbol itself carries no magnitude. One may think of the variable as structurally empty. The emptiness is intentional and accepted. The variable is defined by this openness. The openness doesn't imply uncertainty. It is simply a formal condition. The variable is written consistently throughout expressions. Its identity remains stable in form. The role does not shift over time. We may restate this description in similar language. A variable represents an unspecified quantity symbolically. The quantity is neither known nor fixed. It is not evaluated at this stage. Evaluation is not required for definition. Definition exists prior to evaluation. This ordering is characteristic of algebra. The abstraction is maintained without interruption. The tone remains flat and unchanging. The variable is treated uniformly in all contexts. No contextual meaning is assigned. Only formal meaning is permitted. The symbol functions within a closed system. The system does not reference external reality. This separation is deliberate. We may remain with this concept quietly. The repetition does not alter understanding. A variable is a symbol without fixed value. The statement may be repeated calmly. The meaning remains stable. No further elaboration is required here. We may now consider another algebraic concept. This concept is known as a constant. A constant is also represented by a symbol. The symbol denotes a fixed quantity. The fixed nature defines the constant. It does not allow variation. It can be observed that the value remains the same. This sameness is assumed throughout expressions. The assumption is not questioned. It is part of the formal system. Unlike a variable, the constant doesn't change. Change would contradict its definition. The constant remains stable under manipulation. Expressions may be transformed symbolically. The constant itself remains unaffected. One may think of the constant as immobile. Its immobility is formal, not physical. The symbol refers consistently to the same quantity. This reference does not depend on context. Context does not alter the value. We may restate this idea using similar phrasing. A constant represents a quantity that stays unchanged. The unchanged state persists throughout usage. This persistence is assumed without emphasis. Such assumptions are common in abstract mathematics. The language used remains deliberately plain. No expressive variation is introduced. The constant exists entirely within algebraic structure. It does not point beyond the structure. No interpretation is required. The role of the constant is passive. It supports expression through stability. This support remains implicit. The symbol does not draw attention. It simply remains present. We may remain with this description calmly. A constant is fixed and stable. This statement can be repeated. Repetition does not change meaning. The meaning remains uniform. Uniformity supports monotony. The monotony is intentional. An equation is a formal symbolic statement. The statement expresses equality between algebraic expressions. This equality is indicated by a conventional symbol. The symbol signifies sameness of value. It does not suggest action or procedure. It merely states a condition within a formal system. The condition exists independently of interpretation. It can be observed that an equation is static. The statement does not evolve over time. It remains fixed once written. Each side of the equation is treated symmetrically. No side is considered primary. No side is considered secondary. The structure enforces balance. Balance is assumed and not emphasized. One may think of an equation as a declaration. The declaration asserts equivalence. The equivalence is symbolic and abstract. It does not refer to physical quantities. It does not imply measurement or observation. Variables may appear within equations. Their presence does not alter their definition. They remain unspecified symbols. Constants may also appear within equations. Their values remain fixed. The equation does not modify these roles. It only relates expressions. The relation is formal and unemotional. We may restate this idea using similar phrasing. An equation connects expressions through equality. The connection is represented symbolically. The representation follows established conventions. These conventions are stable and repetitive. Repetition is common in algebraic language. The repetition does not introduce variation. Variation is minimized intentionally. The form of an equation remains predictable. Predictability reduces cognitive stimulation. Reduced stimulation supports passive listening. The equation exists as a complete statement. It does not require resolution at this stage. Resolution is not implied. The statement stands as written. One may think of the equation as a condition. The condition may hold under certain assignments. This possibility remains implicit. It is not explored further. Exploration would increase engagement. Engagement is not required here. The language remains flat and even. Sentences proceed at a steady pace. No emphasis is introduced. The equality symbol maintains its meaning throughout. Its meaning does not shift with context. Context does not alter the formal definition. The equation is part of a closed symbolic system. The system is self-contained. External reference is unnecessary. We may remain within this description for some time. Restatement reinforces monotony. Monotony supports calm attention. An equation states that two expressions are equal. This statement may be repeated. The repetition does not change meaning. Meaning remains stable across restatement. Stability characterizes algebraic structures. The tone remains consistent. The pace remains slow. The explanation does not progress toward conclusion. The equation remains a formal statement of equality. An equation exists within algebra as a stable formal object. It does not depend on interpretation or external meaning. The symbols within an equation retain their identities. A variable remains a variable throughout the equation. A constant remains a constant throughout the equation. The equation itself does not alter these roles. It only places them in relation. The relation is expressed through equality. Equality is a formal condition. It does not imply balance in a physical sense. It is only a symbolic statement. The statement exists entirely within algebraic language. One may think of this language as closed and self-contained. The symbols interact only according to defined rules. These rules are consistent and repetitive. Consistency ensures predictability. Predictability reduces variation. Reduced variation maintains monotony. We may restate this relation slowly. An equation relates expressions without changing their nature. The expressions remain as written. Their internal structure is preserved. The equality symbol connects them neutrally. No direction is implied. No movement is suggested. The equation does not act. It simply exists. This existence is static and unchanging. It can be observed that equations do not require resolution. Resolution is a separate consideration. Here, the equation remains unresolved. The unresolved state is acceptable. It does not diminish the definition. The equation is complete as a statement. One may think of completeness as formal sufficiency. Formal sufficiency does not require outcome. The language remains restrained. Sentences proceed evenly. No emphasis is introduced. We may now consider the equation within the broader system. The system consists of symbols and relations. Symbols are defined by their roles. Relations are defined by equality. Together, they form algebraic structure. The structure is abstract and repetitive. Repetition reinforces familiarity. Familiarity supports passive listening. We may restate these ideas again. Algebra consists of variables, constants, and equations. Variables are unspecified symbols. Constants are fixed symbols. Equations relate expressions symbolically. These definitions do not conflict. They coexist without hierarchy. The system remains orderly. Order is maintained through convention. Convention is shared and stable. No novelty is introduced. Novelty would disrupt monotony. Monotony is preserved intentionally. The explanation continues without progression. No conclusion is offered. No summary is implied. The lecture remains even and unchanged.